Good morning, ladies and gentlemen. Part 2, 8.3, aquatic biodiversity. In this section, we're going to look at how humans have negatively impacted aquatic zones, and we're going to look at a case study of the Chesapeake Bay because it's often referenced in the AP test and on FRQs. So let's do it. Human impacts on marine ecosystems. Humans have heavily impacted 41% of the ocean. You know the ocean is massive. We've only explored roughly 5% of it. We have negatively impacted 41%. 45% of the world's population lives near the coast, lives on or near the coast. Near the coast would be 15 miles or closer. Lots of coastal developments. We do a lot of our growing near the coast, especially as rivers make their way out there and they're moving. We've used that water traditionally to power industrial plants, to dilute our toxic waste as it goes out into the ocean. So oil spills, I'm sure you guys remember the BP, the Horizon oil spill that took place 4 years ago now, which is hard to believe. Lots of invasive species. We move invasive species in and out of the ocean, especially from sea trade. Like if you take a big barge and load it down with containers for shipping goods from China to the United States and vice versa, or anywhere across the world, as soon as those ships go into port and we unload all of those big metal containers, right, now that big ship becomes unstable because it rises out of the water. So what they do is they suck in a bunch of water from the surrounding ocean into holes inside, and it weighs that ship down. It's called ballast water. And then that ship moves from that port, maybe from China, and it comes into the United States, discharges all that water. With it, the viruses and the bacteria that are in the water, the small fish that are in that water, and some of the plants. The zebra mussels that are devastating the Great Lakes came into that area from ballast water. The little tiny larva at that moment in time was a type of plankton, if you remember from the last lecture, and as we discharged it, all right, those larval zebra mussels got a hold in the exhaust pipes of power plants and just fill in those power plant exhaust pipes now, and then clog them, and they can't exhaust that water out of the power plant, and they overheat. And of course, climate change is leading to sea level rise and higher acidity. We discussed this earlier in the year, and we'll come back to that when we get to climate change, as well as sea level rise and how much sea level rise we can expect in the future. One other thing I wanted to say was 70% of China's coastline, and they have a large coastline, it's too polluted for people to go swimming in. That's crazy. In the United States, it's less, but it's still 25%. And in the United States, when people go swimming, 25% of the population that goes swimming gets some type of ear, eye, nose, or throat infection from the fecal matter that is in the water on the coastlines. That's insane. In California, after they have a rain event that dumps 1 inch or more onto land, all that water is going to run off into the coastline. On its travels, it picks up human waste, it picks up animal waste, and it gets dumped into the coastline. So they tell people not to go swimming for 72 hours after they have a rain event that dumps 1 inch or more of water onto the land, because you're at a high risk of infection. That's lovely. Okay, the Chesapeake Bay. It is an estuary, the largest estuary in the United States. And as you see, the water comes all the way in here and goes into all these little finger branches, tributaries off of this estuary. But as the ocean water moves, you can imagine that the water that's all the way back here, it takes a long time for it to ever make its way out and exchange with the coastline, right? So it's not stagnant, it moves, but it doesn't move quickly. So since the 1940s, the population in this area has increased 4 times. We have harvested the oysters and crabs like crazy. That's one cause for the decline. And with all of those people, we've dumped lots and lots of toxins into the bay, which has polluted it enough to keep these organisms from being able to survive. Now, oysters are incredibly important because oysters filter all the water out of the bay. In 1900, it could filter and cleanse all of this water in 3 days. 2010, it takes the remaining oysters 365 days, or 1 year, to do the job that was done in 3 days in the 1900s. And that's, again, a combination of over-harvesting and pollution, industrial waste, sewage from humans, manure from animals that graze along these estuaries and tributaries. So they knew that they had to do something about it, and they're trying to improve the situation. So there is an integrated management system that included the federal government, the state government, local legislation, and citizens working together. That's why this is used as a case study, because it shows everybody coming together to do something beneficial and actually working. So they set up new land use regulations, banned phosphates and detergents. Phosphates, again, remember, are a plant nutrient. So if it gets into the water, the algae go crazy for it. They have updated the sewage plants there to make them efficient, because a lot of them were old, outdated. They were dumping raw sewage, lots of it, into the estuary, and that needed to be stopped, obviously, to get rid of the nitrogen, the fecal matter, the bacteria, the E. coli. The results, they've noticed a 27% drop in phosphorus and a 16% drop in nitrogen. So phosphorus, oh man.
First Sergeant Vasquez, please come to the front office or call 50801. First Sergeant Vasquez, 50801, please.
All right, Sergeant Vasquez, make sure you call them. So the phosphorus comes from the banning of the detergents, and the nitrogen comes from the reduction of sewage into the bay. And that is all for that one. Short and sweet. Short and sweet.